Welcome to Quantum Talks. Today we're diving into the mysterious world of quantum entanglement. It's like, when particles become correlated in such a way that one instantly affects the other, regardless of distance.
Yeah, that's wild. So, just to get it straight, we're talking about particles sharing this hidden connection that defies classical rules, right?
Exactly. It's kind of like they have this secret, instantaneous conversation, no matter how far apart they are. Einstein even dubbed it spooky action at a distance, because it challenges everything we thought we knew about information and speed.
Right, that phrase always gives me goosebumps. But how do scientists actually create these entangled particles?
Great question. One common method is using a laser that shines through a special crystal, which splits a photon into two entangled photons. It's like using a magical prism that gives you a pair of super-connected light particles. There are also methods
I can picture
using
that.
trapped atoms and ions with lasers and electromagnetic fields.
So then, how do they confirm the particles are really in sync or entangled?
They turn to Bell's theorem, performing what's known as a Bell test. Essentially, they measure properties like polarization, and if the values break classical limits, it's proof the particles are entangled.
That's some clever physics there. That's fascinating. And what about real-world applications? I mean, could all this lead to practical technology?
Oh, absolutely. Entanglement is a cornerstone for quantum computing because it allows qubits to work together in ways that classical bits never could. It's also crucial for quantum cryptography, for ultra-secure communications, and even quantum teleportation, where quantum states are sent over distances.
Makes sense. I heard something about a Chinese satellite doing something with entanglement. What's that about?
Yes, you're thinking of the Myceus satellite. It demonstrated quantum key distribution using entangled photons over thousands of kilometers. Picture it as the first step toward a global quantum internet. Really, like a high-tech web of secure connections.
Right, that's impressive. But with all this exciting progress, what are the biggest hurdles that scientists face?
The main challenge is decoherence. Keeping those entangled states intact over long distances in a noisy environment. Scaling up to work with many particles for large-scale quantum computers is another huge, obstacle.
I can see why that would be tricky. Some might argue the practical applications are still a bit, futuristic. What do you say to that?
Fair point. While many applications sound futuristic, these breakthroughs, like with the Myceus satellite, show we're already making headway. It's like building a superhighway piece by piece, rather than waiting for an expressway to appear overnight.
Building block by block indeed. And for someone curious to explore more about quantum entanglement, any suggestions?
Definitely check out accessible reads like Quantum Computing for Everyone by Chris Bernhardt, and explore some quality online videos. Once you get the basics of superposition and measurement, the door to quantum theory swings wide open.
Yeah, those resources do sound like a great start. Incredible stuff. Thanks for unpacking this with such clarity. It's almost like every entangled pair has its own story to tell.
Absolutely. Each connection, each measurement, is a glimpse into the underlying quirks of our universe. Thanks for being curious
Right on.
and diving in with me today.